All right, so when we're asked to find the exact value, although the answer is just, in most cases, just one little thing, there's so much more that has to happen in order to get to that one little thing. So if I look at the first one, it says sine of 150. So I know that 150 is in this quadrant. So if that is 150, then I know that if I drop a perpendicular down, always to the right angle, or sorry, to the x-axis, what I end up, that this right angle triangle is actually then going to be 30. Okay, the reason being all the way around would be 180, and I'm just taking off that little bit. Okay, so 180 subtract 150 gives me 30. So I know I'm looking at the 30-degree triangle. Okay, so the first thing I'm going to do is I know that sine of 150 is the same as sine of 30. The only other thing I have to check out is sine positive or negative in that quadrant. So if I put cast here, okay, well, sine is positive in this quadrant, so life is good. So it's sine of 150 is the same as sine of 30. So then what I do is I reproduce the triangle. Okay, remember we started with an equilateral triangle, cut it in half, and use Pythagorean theorem to get it. So sine of 30, we know here's 30 here, so this is opposite. Here's adjacent and hypotenuse. So sine is opposite over hypotenuse, so my answer is positive 1/2. Okay, now same kind of thing when I go to do the next question. Oops, I didn't want to get rid of all of that. Just my A. Oh, still doesn't like me. There we go. I'll make it happen one way or the other. There we go. And the reason I'm doing that is sometimes I want the 60-degree angle as well. Okay, so here it is again. And I'm going to group it again so I keep it in one piece. The next one is cos of 225. Now, if you kind of get what I did with the first one, you might want to stop the video and keep working. If you get stuck, you always can come back to the video. So cos of 225, same kind of process. 225 is in this quadrant. Okay, so that's 225. I want to know when I draw a perpendicular to the x-axis what that right angle triangle is. Now we know that it is from 0 all the way to the other side of the axis is 180. Okay, and we want to go further than that, so I'm going to subtract 180 from 225 and I get 45. So cos of 225 is the same as cos of 45. Now I just have to determine whether it's positive or negative. Well, cast tells us that in that quadrant only tan is positive. So cos of 225 is the same as negative cos of 45. Now I can pull up my 45-degree triangle, and we know for it cos is adjacent over hypotenuse, so we know our final answer is negative 1 over square root 2. Okay, and I'm going to actually skip down to the sine of negative 60, just so that we have a negative 1. Okay, so we know when we have a negative angle that instead of going counterclockwise, I'm going clockwise. So that means this here is 60 degrees, okay? Because if I'm going this direction, that's negative 60. Same idea as before. I put a perpendicular up to the x-axis. We know that it's 60. So we're looking, sine of negative 60 is the same as sine of 60, but is it positive or negative? Same thing using cast. We can see that only cos is positive there. So sine of negative 60 is the same as negative sine of positive 60. Okay, so then what we do is we bring down our triangle again, and remember it's the same triangle that we used with the 30, except we label it again differently. so that we have, if we're talking about the 60-degree angle, this is going to be opposite, adjacent, and hypotenuse. So this is going to equal negative square root 3 over 2. Okay, so that's how you do the exact values. Exact values can be also used for the secondary trig ratios. So if I had, for instance, instead of the sine of negative 60, I had the cosecant of negative 60, same kind of process. I probably would do something like this to make it a little bit easier for myself. I could do something like that. Or the other thing I could do is I could use the same process. I know this is related to sine. Okay, I know that, so I don't need to go that way. I know that negative 60 is here. This is related to that. And so then what I could do is I could go back to this right angle triangle. So if I'm looking at cosecant of negative 60, that's related to sine of negative 60, which is related to 1 over negative sine of 60. So you could do it that way and then substitute in our answer that we actually got from before, which was negative square root 3 over 2. The difference being is this is over 1, which means I would have to reciprocate it to get rid of the fraction over the fraction, and I end up with negative 2 over square root 3. Or, as I said too, I could figure out using the right angle triangle as well for the negative cosecant of 60. I could do that as well because I know that I'm using this and this. Those are the two things. And sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So you could do it more than one way, whichever way suits you. Just wanted to show you that secondary one just in case you happen to come across it.